Hey there, hope you're having a wonderful day. So in the previous video, we went over scrolling, and by implementing scrolling, we started moving everything else on the map to simulate Mega Man walking left or right. And by implementing this, we are able to move Mega Man across a bigger map. So just to show you what we have so far, you can see we have a bunch of monsters and they can fire bullets, and we have spikes, and we have these platforms which are created using the floor tiles. And of course, Mega Man can walk to the right and walk left. So basically, Mega Man can walk across a much bigger map than before. So we have all the core features implemented. Now all we need to do is design a map and draw the map out for our game. So we're going to get rid of all these platforms and what we have so far in our create map function, and we're going to replace it with a tile map. So a tile map is used to design the map of our game. And if you go to the GitHub repository using the link in the video description, you'll find the repository for all the completed code for each lesson, and you'll also find a tile map file. So if I click here, you can see we have this tile_map.python. So if I open this, you can see we have a tile map. So in this file, we have one tile map, which is this game map over here, and it is represented as a list of lists. So a 2D list. And so basically in the list, we have a bunch of lists, and each list contains a bunch of numbers. Each number is a code representing a tile. So if I scroll up, you can see 0 represents sky, 1, 2, 3, 4 represents different rock tiles, 5 represents floor tile, 6 wall tile, 7 beam tile, and so on. So currently we have 12 different tiles, but for our map, we have 10 different tiles over here, and we have 2 enemy tiles, okay? So these 10 tiles are all the same size. They are going to be 32 pixels by 32 pixels, which is the tile size that we stated in our game. And some of these images we have not used yet, such as the rock tiles and the wall tile and the beam and door. So in order to properly use this tile map, we're going to have to load these images. So how does this tile map work? So here you can see we have two representation of what goes on in our screen. On the left, you can see a bunch of numbers. This represents the tile map. So basically with a tile map, we are dividing our screen into tiles. So here you can see we divide everything into tiles. So now there are a bunch of squares. And in total, we have 16 rows and 16 columns. So 16 times 16 gives us 256. So there are 256 tiles on our window. So if we have 16 rows and each row contains tiles and each tile is 32 pixels tall, then the height of the game window will be 16 times 32, which is 512 pixels. And likewise, if we have 16 columns and each column has tiles and each tile is 32 pixels wide, we get 16 times 32, which is 512 for the width of the window. So if I go back to our code, you can see I hard-coded the value as 512, and that is because we have 16 rows and 16 columns. So here, I'm just going to replace these hard-coded values. So I'm going to add a row count variable, and this is 16. And I'll also add a column count variable, which I'll assign to row count. So basically, our game window is going to be a square. And now the width is just going to be tile size times column count. And the height is going to be tile size times row count. Okay, so if I save and run the program, you can see the window size doesn't change. Okay, so the math works out correctly. Alright, so back to our tile map explanation. So on the left is a representation of our 2D list. So basically we have rows and each row has columns. Each column has a number. So the number corresponds to a tile, which is why it's called a tile map, because we are mapping the number code to a specific tile. So if we have 0, that is empty. So there's no tile. So this is going to be an empty space, and we're just going to not draw anything if there's a 0. And if we don't have a 0, for example, we have 5 over here, we're going to draw a tile. So 5 is going to be the floor tile. And here you can see we have 1, 2, 1, 2 alternating and 3, 4, 3, 4. 1, 2, 3, and 4 correspond to 4 different rock tiles. And if you order them in this structure where you have 1, 2, 3, 4, these 4 rock tiles combine together to make one larger piece of bedrock. So over here we have 1 unit, okay? So that's how you can make bigger images by combining smaller images. So how do we translate this in code? So basically, we're just going to iterate through our tile map. We're going to go through each row, and in each row, we're going to go through each column. So we're going to start at row 0, and we start at column 0. So tile map of 0, 0. What is the value? We have 0. Therefore, we're not going to draw anything. So we're going to go to the next column, which is column 1. We get 0 again. So we're not going to draw anything. We continue to the next one, and the next one, and so on, until we get to this row over here. And then we see we have a 5. So we're going to create a floor tile, and we're going to append it to the tiles list. Now, when I say 0, 1, 2, 3 for the columns, these are column numbers. If I want to, let's say, draw a tile here at this specific position, I would need to multiply the column numbers and the row numbers by tile size. Because we are dividing our game window into tiles, we need to jump 32 pixels each time. So here would be column 4, and this would be 4 times tile size. So this is 4 times 32, which is 128. Okay? And the row would be 2. So it'll be 2 times tile size, which is 32 times 2, and we get 64. So when we are iterating through the tile map, we need to multiply the row or column by 32 pixels when we are actually assigning the X and Y position of that specific tile. So right now it might be a bit confusing, but hopefully when we are actually coding it out, you'll have a much better understanding on how this works, okay? So let's go back to the code. Alright, so for our tile map, we need to import this map. So this map is called game map 1. So I'm going to do import tile map. So this is the name of the file, okay? tilemap.py. And I'm going to create a variable game map, and I'll just assign it tilemap.gamemap1. Now before we actually create our map, we need to load some of these images. So we have this door tile, which is the entrance to the boss in our Mega Man game. And we also have this beam tile, which is pretty much decoration. And we have the room tile, which is decoration as well. So Mega Man will not be able to collide with this specific tile. This is just for visuals. And then we have these rock tiles and the wall tile. So we need to load all these images into our game first. So let's scroll down, and over here we have floor tiles. Since we have a lot of tile images, I'm going to separate them like so. So now we're going to separate the tile images from the player related images and the monster related images. So we have floor tile image. Now the next thing I want to load is the wall tile image. So the name of the file is wall-tile.png, and the width and height is just going to be tile size and tile size. Okay. And let's also load the beam tile. So beam tile image. This is load image of beam-tile.png. We have tile size and tile size. And then we have our 4 rock tiles. So rock tile 1 image. This is load image rock-tile1.png, tile size and tile size. And I'm just going to copy this 3 times, and we just change each one. So this is 2, and the file name is rocktile2.png. Then we have 3, rocktile3.png, and then 4 and rocktile4.png. Now let's add our door tile and room tile. So door tile image is going to be load image door tile.png. And then we're going to add room tile. And as I mentioned before, some of these tiles are only used for decoration. So we have this room tile and we have these beam tiles. Essentially, these tiles are in the background. So megaman would not be able to collide with these tiles. Instead, we're just going to draw them. So for that, I'm going to create a new list. So let's scroll down. And over here, we have a tiles list. I'm going to create another one called background tiles. So this is going to store all of the tiles that we're going to draw, but not use for collision detection. And since this is another list, we need to update the draw function for this list and the move map x function. So let's scroll up. And for the draw function, I'm going to do for tile in background tiles, window.blit, tile.image, tile. And let's go up to our move map x function. And we're going to do the same. So let me just copy and paste this so it's easier. And I'm just going to replace this with background tiles. Okay. And of course, we are just checking tile collision with the tiles list. So this will not affect background tiles. Alright, so I think we have everything set up. Now let's go to our create map function. Alright, and in our create map function, we have a bunch of for loops, and we're going to get rid of all of this code. So you can say goodbye to this code, which we've spent 20 lessons writing, and we're going to replace it with a map. So as I mentioned earlier, we need to iterate through our tile map. So I'm going to do for row in range length of the game map. So this is the number of rows in our game map. And we actually have 16 rows, which corresponds to the number of rows in our game window. But for the number of columns, we have quite a lot. Okay? But that's okay because megaman is moving with scrolling. So we can expand the map as much as we want horizontally, since we're just sliding everything horizontally in the x direction, left and right. Alright, so in our create map function, we iterate through each row and we need to iterate through each column in that row. So for column in range length of game map of row. And here we're going to get the map code, which is game map of row column. So this is the number. So the map code is going to be these numbers over here, and they correspond to a tile that we set. And then we need to calculate the x and y position. So remember, the row and column numbers are for each tile. The x and y position are for the pixel. So the x and y position represents the top left corner of each tile, how far we are moving from the top left corner of our game window. So the x value is left and right, so this is going to be column times tile size. So if we're in the 0th column, this will be 0. Column 1 is going to be tile size, which is 32 pixels to the right. Column 2 is going to be tile size times 2, which is 64 pixels to the right, and so on. And y is going to be row times tile size. So we have our x and y position. Now we just need to figure out what we need to draw. So this is going to depend on the code. And basically, we're just going to create a very long if-else conditional statement. So if map code is equal to 0, we're going to continue. So this is going to ignore the rest of the if-else chain and just go on to the next iteration of the for loop. So 0 is an empty tile. There's nothing to draw. So we move on to the next map code. So elif map code is 1. So 1 is going to be a rock tile. So I'll do tiles.append, and here we're going to create a new tile. We need to pass in the x and y position and the image. So rock tile 1 image. And I'm going to copy and paste this. Okay, and we're changing this to 2. Image name is going to be rock tile 2, 3, so rock tile 3, and 4. Rock tile 4. Okay, elif map code is equal to 5. This is the floor tile. So actually, I'm just going to copy and paste this since most of the map code corresponds to an actual tile. So instead of rock tile 4 image, 5 represents a floor tile. And let's copy and paste this and change this to 6. So 6 is going to be wall tile. And then next we have map code is equal to 7. 7 is the beam tile. And as I mentioned earlier, the beam tiles are for decoration. So instead of appending beam tiles into the tiles list, we're going to use the newly created background tiles. So background tiles.append tile x, y, beam tile image. Next we have elif map code is equal to 8. So 8 is spikes. So spike.append tile x, y, and spike image. Alright, so we have 4 more to go. Map code is 9. This is the door tile. So background tiles.append tile x, y, door tile image. elif map code is equal to 10. This is the room tile. So background tiles.append tile x, y, room tile image. Finally, we have 11 and 12. 11 is for metall and 12 is for the blader. So elif map code is equal to 11 metalls.append metall x and y. And finally, we have 12, which is bladers. Alright, so basically, we're iterating through the tile map and we are just checking to see which map code we get. And depending on the map code, we create the object and append it to the appropriate list. And then our draw functions, move functions will handle everything with those lists. Alright, so let's save and run the program and see what our map looks like. And here we go, we have our map. And if I go to the right, you can see we have a metall enemy. And currently we need to walk a little closer so that metall can exit defense mode and start firing bullets. And we can also fire bullets. We have an item. Okay. And over here we have some spikes. And here we have a hole. So currently we don't have the concept of game over and scoring. So if you fall into this hole, then you're just going to fall forever. But you can still walk left and right. So I'm going to restart the game just so I can show you the completed map that I created. So let's destroy these metalls again. Okay, let's walk. Spikes. We have a blader here. Come on. Oh, okay. And we have a bunch of bladers here as well. Okay. And continuing on. More monsters. I'm just going to skip them. And you can see we have some beams down here. And the idea here is we're not going to collide with these beams. These are background. So Mega Man can just walk through these beams. And if Mega Man falls down here, then Mega Man will lose all of his health, since touching a spike will destroy all of his health and cause the game to be over. But since we don't have that implemented, I'm just going to keep on walking. Alright, and I'm just going to ignore these monsters. Well, I'll take that one. And you can see we end up in this final part of our map. And essentially this door is going to lead us to the map where our boss is. I was considering putting the boss in the same map, but I decided I want to put the boss in a new map just to show you how you can load a new map, or basically the next level, after completing the current one. So right now, Mega Man can just walk through, and this is where our map ends. And the nice part about how this code is set up is if I want to add something to the game, all I need to do is edit the tile map. So let's say I want to add some more metalls. Randomly, I'll add one over here, change this from 0 to 11. And we're just going to have metalls fly out of the sky. Maybe for some reason, I want to have tiles over here. So let's add some floor tiles up here just to show you what that will look like. And you can play around with the map, just change the numbers around. So let's add a blader here, and I'm going to click save. Now let's go back to our main file, and if I save and run the program, you can see we've added some floor tiles over here, and these 3 metalls dropped from the sky, and we added this blade over here. Okay? So you're free to design your own map. I'm just going to leave this map for you over here, and of course, without these changes that I made just now. So let's get rid of those changes. Alright, so that's pretty much how a tile map works. And in the next video, I'm going to show you how to optimize the tile map, because currently we are not creating the tiles in an efficient manner. So yeah, that's it for this video. Hopefully you found this video helpful, and if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And as always, if you want to stay up to date for more Python game programming tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.